Hey, go on coming today.
Study.
Study what?
Huh? Only meh? Every day I study 4-5 hours, you know.
Oh, but I don't study, yeah. Hey bro,
Hey, what's up?
where you going ah?
I'm going to basketball, bro.
How come you can always play sports but still score so well ah?
We need to exercise to improve the immune system.
Hi, I'm Tian Qing and we are from Team 4. Together with me are my teammates, I'm Peng Kiet, Zuriel and Victor. So for our problem statement, according to a NUS study, students in Singapore spend over 45 hours every week studying. This can lead to multiple health issues that will affect students' exam scores. Hence, we are interested to find out if exercising, along with other factors, will affect a student's exam score and the optimal hours a student should study. Moving on to our data collection process. We have collected our data from a Kaggle dataset, student performance factors, based on 6,607 observations, and some factors of it include hours studied, sleep hours, attendance, previous scores, and physical activity.
Okay, hi guys, my name is Victor. Okay, so by central limit theorem, when the sample size is large enough and n is equal to or more than 30, by CLT, we can assume the distribution of our sample follows that of a normal distribution. Since our dataset has a sample of 6,607, we can apply CLT, and when we calculate the mean of the sample, we will follow that of a normal distribution, which is nu, and the variance is nu is sigma squared over n. Also, we have to assume IID, which means independent and identical distribution. Independent means that each random variable is not affected by any other random variable in the set, meaning the outcome of one variable does not have an impact on other variables. Identical distribution means that each random variable follows the same probability of distribution, and they have the same probability of taking different values. Hence, in our case, it will be 6,707 imaginary sample points, which will not affect any other sample point when we use CLT and IID to analyze the sample. Now, we will use a linear regression model to analyze how the 5 key factors we identified earlier relates to students' exam scores. So, the exam score will be the dependent variable, or the independent variables will be factors such as hours studied, attendance, sleep hours, previous scores, and physical activities. After we use RStudio to compute, looking at the dataset, the final equation will be as such. Now, all independent variables are technically significant except for sleep hours. Since we are only interested in how physical activity is applied to student exam scores, we will ignore the other independent variables. Now, looking at the coefficient for physical activity, which is a positive 0.154, which means the increase in one unit of physical activity will increase exam scores by 0.154, holding other independent variables constant. This result is statistically significant, shown by its extremely low p-value. Thus, we can infer that physical activity does play a part in students' exam scores. And our multiple aspect value is 0.5736, meaning that 57.36% of variability observed in exam scores can be explained by our independent variables combined. Lastly, our model adjusted R-squared value is bigger than 0.5, hence we can say that this model is a good fit.
Hi, I'm Kinke, as you can see from here. So moving on to hypotesting. Our hypothesis testing, we are trying to find out whether or not students with a physical rating of 5 indeed score better in terms of exam score compared to the rest of their peers with a physical activity rating of lower than 5. So we come out here with mu2, which is the average exam score of students with physical activity rating of 5, and mu1, which is the rest of the students with physical rating lower than 5. So our hypothesis is we use mu2 minus mu1 is less than or equal to 0, and our alternate hypothesis is that mu2 minus mu1 is more than 0, which is what we are testing up for. So from here you can see the average exam score of all the students in the data set. So you can see the average score is about 67.235. Moving on, we also found the standard deviation of all the exam scores. And then moving on, we found out the mean of the students whose physical activity rating is 5, and this is their average exam score. And then the sum of the number of students that is with a physical activity rating of 5. And then using the Z formula, we can find out that the Z score is 1.798, and then using that into our p-value, we get a value of 0.0360, which is lower than 0.05. Therefore, at 5% significance level, we can conclude that there's sufficient evidence to reject the null hypothesis. Since we have sufficient evidence to reject at 5% significance level, it means that the alternate hypothesis is true.
Hi, my name is Zuriel, and today I'll be explaining the portion on confidence interval. So on top of just doing a linear regression model and hypothesis testing, we also constructed a 90% confidence interval for the average hours studied by a student with an exam score of 75 and above. So first, we have to find the sample mean, which is the average hours studied for those with an exam score of 75 and above. And that would be 36.26613 hours. Next, we have to find the standard deviation of hours for those who studied with an exam score of 75 and above, which is 7.765997. And lastly, we have to find the sample size of those who studied and scored above 75, and that will be 124 students. So now we can finally find the lower and upper limit. As you can see here, as we do not have population variance, instead of using a normal distribution, we have to use a similar distribution, also known as a t-distribution. So following the t-distribution and a confidence interval of 90%, we can therefore find our lower limit and upper limit, which is 25.11029 and 27.42197. However, this raises the question, what if our population is not normally distributed? Can we still apply the confidence interval formula? Yes, we can. By only under the condition that the sample size is large enough, and the sample size has to be more than 30. So, by the merit of central limit theorem, the sample mean will still roughly follow a normal distribution, which means the same confidence interval formula can be applied.
So combining the above, we have came up with two solutions to our problem statement. The first one being implementing physical education to all institutes of higher learning, as it has been shown that students' exam scores increases with higher physical activity. The second one being implementing optional 5 hours group study sessions for students. So moving on to our limitations, the first one is that our adjusted R value is not very close to 1, as there are other variables that are not measured, therefore not included in the linear equation, some of which are intangible, such as stress level and family problems. The second limitation is that the values are not reflective of the Singapore context, as the dataset is obtained globally. Therefore, that comes to the end of our presentation. Thank you.